everybody. Welcome to lesson 3.1. Ready to start chapter 3, where we're all about learning to solve equations. This is the real algebra crux. This is the most important part as you're leading into algebra to make sure that you get a great foundation. Our first lesson is going to be all about adding or subtracting to solve equations. So it's important that before we begin, you get a good idea when you're solving an equation. The goal is to get the variable by itself. So you want the variable on one side of the equal sign and everything else on the other side of the equal sign. That's your goal. So to do that, to isolate that variable, you have to undo whatever math operations are happening to that variable. And the way that we undo them is that we use what we call inverse operations. So for example, some addition and subtraction are inverse operations. You can see multiplication and division are inverse operations. And another example, squaring something and taking the square root. These are also inverse operations. So for example, the way that you use this is adding a number and subtracting that same number will undo an operation. Let's look at some. That's what we're going to be working through today. The other thing to make sure that you understand, even though several of these you can do without having to show every step, that's not the important thing. The important thing is that you learn what your work should look like, which means you need to show every step. All right, let's look at this first problem. Here's my variable. It's my y. You can see that right now I'm subtracting 5 from my y. So what is the inverse of subtracting 5? Well, it's adding 5. So I'm going to add 5 to both sides of the equation. And what I wrote over here is like my own little checklist, my own little to-do list for what I need to be able to do in order to solve this problem. So I need to add 5 to both sides. So I'm going to add 5 here, and I'm going to add 5 over here. On the left side, this minus 5 and this plus 5, those are inverse operations, so they cancel each other out. That means the only thing left over here is this y. So I end up with y is going to be equal to negative 7 plus 5 will give me negative 2. I've done my checklist. I am finished. The best part about this for a lot of you is that you can go back and check your answers and know right away whether you got the answer right or wrong. So I'm going to take that negative 2 and I'm going to substitute it back in where that y is. So it would say negative 2 minus 5 is equal to negative 7. So negative 2 plus a negative 5 is negative 7. So you'll notice on both sides of the equal sign I have the same thing. So it checked, I did it correctly, and that is the right answer. And you can check each and every problem to make sure that you get it correct. Okay, on problem 2, here's my m. And what's happening to my m? Well, I have a lot of times that you guys will tell me what's happening to this m is that I'm adding 10. But if you look at the 10 is not positive. The m is positive. The 10 is actually negative, so I'm really subtracting 10 here. So the opposite of subtracting 10 would be adding 10. So I'm going to need to add 10 to both sides of the equal sign. Okay, negative 10 and a positive 10 cancel each other out, which leaves me just an m. It's going to be equal to 8 plus 10 gives me 18. Again, I can go back and check it and say negative 10 plus 18 is equal to 8. And then I can check the math. 18 take away 10 is 8. So I did it correctly, and I got the right answer. Okay, for the following problem, You can tell right now that I'm adding 18. So to make it go away, I'm going to have to do the opposite, which is going to be subtracting 18. So I need to subtract 18 from both sides of the equal sign. That crosses them out over here, so I'm just left with an R. It's going to be equal to 5 minus 18 is going to give me negative 13. I encourage you to go through and check them, but I'm not going to check every problem because I know that you can do that part by yourself, and I want to allow you the ability to go back and check your work. For this next problem, you'll notice my x is actually on the right side of this equation, but that makes no difference. I still look and I say, what's happening to my x? Well, to my x, I'm adding 14. So if I want to undo that operation, I'm going to have to do the opposite and subtract 14 from both sides. I'm going to subtract 14 over here, and I'm going to subtract 14 over here. It's going to give me x is equal to, after these cancel, negative 14 plus 3 would give me negative 11. For these last two problems, you need to do a little bit of simplifying before you start working them out, because you'll see right here I don't have an answer simplified, and over here I don't have my answer simplified. So we do want to go ahead and do that before we go through the process of solving. So when I do that, the x minus 9 didn't change, but on the right side, 6 times negative 2 would give me negative 12. Now I can say, here's my x. What's happening to that x? Well, you can see right here that you are subtracting 9. The inverse of subtracting 9 would be to add 9. So I'm going to do that to both sides of my equation, which will give me x is equal to negative 12 plus 9 gives me an answer of negative 3. For the last one, we said we needed to go ahead and simplify that part. So I'm going to have x plus 33 is going to be equal to 9 take away 24 would give me negative 15. Now I can say what's happening to this x? Well, right now I'm adding 33. To make it go away, I'm going to have to subtract 33 from both sides. So subtract 33 over here and subtract 33 over here. So that's going to give me x is equal to negative 15 take away 33 would give me an answer of negative 48. So that represents all of the equations here on the first page, where you've gone through and worked them using either addition or subtraction. Okay, I'm going to clear these because on the next page, we're still going to be doing that same thing, except now we're going to have to write our own equations first. So we're going to need to write the mathematical equation and then solve it. Okay, so it says a number increased by 8 is 43. So I'm going to decode this math language here. A number means our variable, so I'm going to use n for a number. Increased by is an addition word. We did addition words last chapter, so you can go back and look at those if you're not sure. And it's increased by 8. That's easy. There's a number there. My math word is here means equals. So now I have everything I need in order to be able to write this equation. So a number increased by 8 is 43. Now I can say what's happening to my n is that I'm adding 8. So to undo it, I'm going to subtract 8 from both sides. So minus 8 here and minus 8 here. That'll leave me with just an n on the left side. It's going to be equal to 43 minus 8 would give me 35. And that is the correct answer for this set. Move that up for you just a little bit, make it easier to see. There you go. Okay, for the second problem, you can see that you have 12 less than a number is 4. 12 less than a number is 4. Be careful because 12 less than is a part that confuses everybody. So I'm just going to underline it here for a minute, and I'll explain it a little more in just a second. We know that a number means our variable. Again, I'm just using an n. Is our equal sign. But when it says 12 less than n, what that actually means is take n and subtract or take away 12. And that is equal to 4. And if you say, what's happening to your n? You're subtracting 12. So to undo it, you're going to add 12 to both sides. Add 12 here and also add 12 here. That will give me n. It's going to be equal to 16. For our final one, we have a word problem where it asks us to both define the variable and write and solve. So we've just done write and solve. Now we have to define the variable. What that means is say what the variable is representing or what it stands for. So let's read the problem. It says, when Elise was checking her bank balance, she realized that her purchase of $86 caused her to be overdrawn by $12. What was her bank account before the last purchase? So what are you trying to find? That's going to be defining your variable. Well, I'm trying to find her bank balance. So I'm going to use the letter B, and I'm going to say that equals her bank balance before the purchase. Because we already know that right now her bank balance is negative $12. That's what it means to be overdrawn by $12, is that she has negative bank balance. So if I take that original bank balance, that's my B, and I subtract a purchase, because when you spend money, it subtracts it from your bank account. So I take that B, I subtract my purchase of $86. Her total now is to be overdrawn by 12. That means negative 12. So B represents the bank balance before the purchase. You're subtracting $86, that's what she spent, and you're ending up with negative 12. So then to solve it, right now I'm subtracting 86, so I want to do the opposite and add 86 to both sides. So these cancel, I end up with just a B. It's going to be equal to, when I take 86 and I subtract 12, I end up with 74. So her bank balance before her purchase was $74. So I can now put my dollar sign on here because it was $74. All right, good luck this week, guys.